Hey guys, this video is about moles and mole to volume relationship. Okay, so we're going to be looking at the mole and going to volume in liters. Okay, but first off, let's talk about Avogadro's hypothesis. Avogadro's hypothesis states that equal volumes of gases at the same temperature and pressure contain equal number of particles. Perfect. Okay, so given that they're this same volume, they will have the same number of particles. Okay, now let's talk about standard temperature and pressure, abbreviated STP. Okay, what STP is, it means a temperature of 0 degrees Celsius and a pressure of 101.3 kilopascals. Okay, so if you're at 0 degrees Celsius and at 101.3 kilopascals, you are at STP. Now, there's a few different pressure units that we can look at. Another important one is atmospheres or ATMs. In the United States, we have PSI, pounds per square inch, but we don't use that one. And the other one is mmHg, millimeters of mercury. We don't really use that one too much in science either. So it's mostly kPa or atmospheres. If you check on your car tires, your bicycle tires, you will see a kPa because in Europe they use kilopascals. Now, at STP, so if you're at 0 degrees Celsius and 101.3 kilopascals, 1 mole, or Avogadro's number, 6.02 times 10 to the 23rd representative particles of any gas occupies a liter of 22.4 liters. Okay. Okay, so here's an important note. So, no matter which gas you have, 1 mole of that gas will occupy a volume of 22.4 liters as long as you are at STP. Okay? Now, what do we do with these numbers? So what's going on here? Well, we're going to be calculating the volume and moles of a gas at STP. So the molar volume is used to convert between the number of moles of a gas and the volume of the gas at STP. Okay, so there's a conversion factor. The conversion factors for these calculations are based on the relationship 22.4 liters equals 1 mole at STP. So here's your two conversion factors, which you're going to use to convert. Okay, now if we look at the mole map, you're going to see these two conversion factors on there. Okay, one is to go one way and one is to go the other way. Okay, so just remember the one in the denominator is going to be the one that you're going to be canceling out, or you're starting with. So this one here on the right is where you want to go from liters to moles. This one on the left is where you want to go from moles to liters. Okay, moles in the denominator, so it'll cancel out with the numerator of your given. Whereas this one here is your liters, it'll cancel out with the liters of the given. Okay, so if you look at your mole map, you'll see which arrow is going in which direction, and you can confirm which one to use at that time. Okay, so we're going to do one step converting between moles, which is little n, and volume, which is liters of a compound. There's two parts. Okay, part one. We're going to go from moles to liters first. So let's look at a problem here. So moles is here, liters is up here. So we're going to be going up this direction here. We're going to use this conversion factor that has the 22.4 liters over 1 mole. You don't have to do anything with this conversion factor. You use it as is. The only thing you have to do is put the name of the formula of the compound here, and that's it. Okay, so let's start out. How many liters of H2 gas are present in 1 mole of H2 gas? Okay, so we're looking for liters. So we're given moles. So start where you're given. 1.00 mole, 3 sig figs. Multiply it by the conversion factor. Okay, 22.4 liters of H2 over 1 mole H2. Okay, cancel out like units. The H2 cancel out, the H2 cancels out. Solve. Okay, you multiply the 1 by 22.4 divided by 1 is 22.4 liters of H2 gas. Not too bad, it's actually pretty simple. Okay, let's look at part 2, converting liters to moles. Let's go in the opposite direction. Okay, so in this case, we're going to be going from here, volume of a gas in liters, to here. So we're going to be using this conversion factor right here. Okay, so how many moles of chlorine gas are present in 17.9 liters of chlorine gas? Okay, so let's calculate the number of moles. Okay, start where you're given, 17.9, 3 sig figs of chlorine gas. We're going to multiply it by our conversion factor. Okay, 1 mole Cl2 over 22.4. Notice it's the reciprocal of the last conversion factor we used the other problem from practice problem 1 here. Okay, now cancel out like units, the Cl2 and the Cl2 cancel out. Okay, sorry, the liters Cl2, the liters Cl2. Okay, then we solve 17.9 times 1, 17.9 divided by 22.4 is 0.799, 3 sig figs. Okay, 2 simple practice problems right there. Now, what I want you guys to do are do these 2 problems here on your own. Okay, the first one here is in moles. You want to convert to liters. The second one's in liters. You want to convert to moles. So take a couple minutes, write these down. Okay, and then let's check your answers in a sec. Okay, so for your answers for the first one here, you should end up with 13 liters of SO2. And for the second one, 0.251 mole H2. All right, guys, that's the end of the show. Talk to you later.